Learning target 1c continued. I can identify the domain of a function from an equation. So we're given our first function, f of x equals x squared minus 2. The first thing we want to think about is what parent function is this. Hopefully by now you recognize this as the parent function of x squared. And we want to find the domain. So as we think about this parent function of x squared, we need to ask ourselves if there are any restrictions to numbers that we're allowed to square. So we might ask ourselves, are we allowed to square negative numbers? Are we allowed to square 0? Are we allowed to square positive numbers? And the answer to all of those is yes. We can square any real number. So this particular function has a domain of all real numbers because we are allowed to square any real number. So that would be our domain. All quadratics, all parent functions of x squared have a domain of all real numbers. Our next function, this f of x equals the square root of x plus 3. We want to again ask ourselves what the parent function is. Well, this time the parent function is the square root of x. So we want to think about the domain of the parent function. So we're going to repeat the same process. Are there numbers that I cannot take a square root of? Can I take the square root of positive numbers? Yes, I can. Can I take the square root of 0? Yes, I can. Can I take the square root of negative numbers? Well, I cannot take the square root of a negative number and get a real answer. So my domain is that x must be positive or 0. So therefore, the domain of the parent function, x is greater than or equal to 0. Now, how does that help me find the domain of the given function? Well, we are given a restricted domain because the parent function has a domain that x must be greater than or equal to 0. That is a restriction on our domain. Our domain has been restricted. It is very important. So what we're going to do is we're going to take the function that we're actually given, square root of x plus 3, and we're going to set that greater than or equal to 0, and we're going to solve for x to find our domain. So if we square both sides of that equation, we have x plus 3 is greater than or equal to 0. We would then subtract 3 from both sides. And we have x is greater than or equal to negative 3. Therefore, the domain of the given function, f of x equals the square root of x plus 3, is x is greater than or equal to negative 3. Let's look at another function. F of x equals 1 over x plus 2 minus 4. The parent function of this would be 1 over x. It is a rational function. Do we have any domain restrictions? This one is tricky because can we have negative numbers in the denominator? Yes, we can. Can we have positive numbers in the denominator? Yes, we can. But we cannot have 0 in the denominator. Therefore, the restriction on the parent function is that the denominator x cannot equal 0. So we do have another domain restriction. This time we have that we cannot equal 0 in our denominator. So what we need to do is we need to set the denominator not equal to 0 and solve for x. So again, we'll just subtract 2 from both sides, and we'll have x cannot equal negative 2, because x plus 2 cannot equal 0. So my domain is all numbers are allowed except x cannot equal negative 2. Now on this last example, we have a logarithmic function as our parent function. The equation f of x equals log of x plus 6, so the parent function is log of x. The domain of a logarithmic function is that your x value must be greater than 0. You cannot take a log of a number that is not positive. 0 is neither positive nor negative, but you can only take logs of positive numbers. So we once again have a domain restriction. And we will set what they give us greater than 0 and solve for x. So they're giving us x plus 6, so x plus 6 must be greater than 0. Again, we will solve for x by subtracting 6 from both sides, and we find that we have a domain that x must be greater than negative 6.